Well. Hello everyone and welcome into yet another episode of Make It, starting the stream on the right channel because they didn't have the wrong channel stream key inserted into OBS. And today we will be starting the live stream on the right channel. Hello everyone, welcome to yet another Chow Checkup Day 379, the Walking Wednesday Chow Checkup, where we'll be doing 3D and such. Yeah, we'll just take a second to make sure that everyone can join in, give everyone some time to actually join in the live stream. And in the meantime, I can show you something kind of cool, in my opinion, at least kind of cool, with Blender. Present geometry nodes, let me just show you this screen. There we go. This Hide the Nitro, I should be able to see it on Twitch probably. I think so. Anyhow, I switched up the geometry nodes. Last time we streamed on the shitpost channel. I switched down the geometry nodes a bit, so now they're more reasonable. So basically, right now, the way they work is we have a matrice, we have a vector, and we have a vector that's created by the matrice. And the way it works is basically we can define the basis vectors. I'm really proud of this, not gonna lie. This is actually really cool. Right here we've got basis vectors. 1, 0, 0, 1. Right here we've got our basis vectors. Why is this one so short? If I had a nickel for every single time I had that, am I right? Once if we put this to 0. Okay. Oh, I think it's so short because of this. Oh yeah, right. I'm an idiot. 1, 1, 1. Oh, let's do 10, 10, 10. I feel like that would be better. Hi there, on the YouTube. Welcome. And there we go. So, I know everything is jittering a bit because I'm using cycles. Let's switch to Eevee just for this live stream. So here's the thing. Oh, it feels so much better. My CPU will not be thankful, but yeah, it feels so much better. So here's the thing. Here's how this works. Hi, there also like hello everyone, welcome. So here's how matrices work. We have a matrice which we use to transform a vector, and then we get a new vector in return. So this matrice just notes down the coordinates of basis vectors, so these arrows, which means we can take them and we can actually move these basis vectors around. Like for example, the red one, we can put more to the right. Or we can put the red one a bit up. Or we can move the green one a bit to the right as well. Or we can move the blue one a bit to the left. And then forward. That's what matrices are. What's the topic being discussed here? Linear algebra. Here we have a matrice which is transforming this vector and we get a new vector in return. I just set up these geometry nodes which should visualize it decently, and now you can see how, by the way, now we can also see how vectors aren't, how it's not really that useful, how misleading it is, in fact, to talk about vectors as 3D arrows, because right now, when we move this arrow forward or backwards, it basically changes just how important, in quotes, just how changes the magnitude of the green arrow. If we move it to right and left, it changes the magnitude of the red arrow, and if we move it up and down, it changes the magnitude of the blue arrow. That's because talking about vectors as 3D arrows is just a misconception. It's just a massive misconception, but this is the basic idea of how it works. This is actually I'm really happy with how this turned out, honestly, not gonna lie. And today on this walking live stream, we'll use this to explain vectors, to make a segment in the video explaining vectors. A segment in which we will explain not only vectors but matrices mostly. So a segment which we will script, which we will record, which we will animate, which we will render, which we will edit, which we will finish this live stream. And hopefully we'll also get into some calculus. Hopefully, that's the hope at least. Wait a second. For everyone to join, I'm back to coffee and it feels great. We should play some music probably, right? Like I said, decent idea. So what are we in the mood for? Did I just hear copyright free Soda KC on YouTube. Is that what I just heard? I love the videos recently, but can you talk about topics more in depth? That's what I'm trying to do here. I'm trying to talk about this topic more in depth because recently I made a poll on my channel. Let me show you what I mean first. So recently I made a poll on my channel, right in the community tab. This poll, right? And people decided that I should upload long form and short form videos whenever they're done. So basically, the way I'll do things from now on is I'll upload long form videos talking about the talking about the topic in general. So, for example, my electric versus electronic video, right, where I just talked about electricity and electronic stuff and electronics circuit and stuff like this. And then every now and then I'll also release shorter videos talking about the topic more in depth. So, for example, after I finished this video, I could have uploaded another one talking about the physical aspect of electricity. So what sort of physics actually makes electricity happen? Or electronic circuit, something more in depth, like for example, exactly going in from addition to CPU, something like that. And right now we're actually, on this very live stream, we will be working on a short form video. Shorter, it's still gonna be half an hour long. Well, okay, maybe not half an hour, around 20 minutes, but a shorter form video about math, about linear algebra, about calculus, about all of these things in depth. That's the idea. Let me just open up my script. Oh no, don't cancel stream. That would have been a pretty colossal misclick. Okay, so where should we begin? How about at the beginning? That's a good enough place to start, I believe. Okay, what's the beginning? That's a good question. What should we start with? Scripting or animating what I already have? I feel like animating what I already have would also be decent enough. So, geometry nodes, a matrix. Oh yeah, music. I already forgot. Music playlists. We'll play the best hits of Soda KC 2023 music. As always, link in the description. youtube.com/soda@sodakc. Is quantum computing on the list of subjects to do a vid on? Maybe. I'm not an expert in quantum computing though. I mean, all I know about quantum computing is that instead of, unless you're talking about the physical aspect, but if you're talking about the computer science aspect, then all I know is that they, instead of bits, instead of 0 and 1, they use 0, 1, 2, 3, which, well, it's not that interesting of a change, honestly. It is an exponential, right? But it's a cool change, but not interesting to make enough to make an explanation about it. No, I mean the physical aspect. Yeah, for the physical aspect, then I would just need to do a quantum mechanics video, honestly, which I'm working on. This is the music too loud, or is just? Is it the music too loud, or is it just the volume? There we go. I think that's much better. Feels like a speech jammer. There we go. I think we are ready. So, actually right now what I'm trying to do is I'm trying to make a math video. This is gonna be the math video, which will explain all the math required to get into quantum mechanics. And I'm gonna make a quantum mechanics video, which will explain all of the quantum mechanics that's required to get into chemistry. Well, not required that, but all of the quantum mechanics that's underlying chemistry. So, matrices. I would like to explain matrices with a pretty cool... How'd you get into explaining these things? I just make videos, honestly. That's both how I got and how I get and how I'm still doing it. I don't know, I don't have a social life. I need something to fill in the void, so I started doing YouTube. That's just good enough. Anyhow, here's what I would like to make this explanation be all about. I would like to take this vector, and just any good old vector will do, and I want to showcase how matrix works based on... Oh, I have an idea. I have a pretty solid idea of how we could change it a bit to make this a bit easier on ourselves for now. which is we can take these, all of them, and then vector, constant vector 1 0 0, or even easier, we can separate them per rate and then combine. And then here's what we can do. We can actually mix vector, and this is a very nice form of mixing, because using this form of mixing, I'll explain what I'm doing in a second. Just need to 1 1 1. I have no idea which way is 1 actually. Okay, so 0 for all of them, X, Y, Z. Okay, and so here's the thing. Right now, we basically have a setup in which... All the music, by the way, in this live stream is made by Soda Guy. Soda KC. I'm still not used to the nickname change. It's been over a month. Now what we have is we basically have a node system in which we can set up any matrix we want, like for example something like this kind of matrix, right? And then we basically have a system of weights which we can use to... I did it wrong. Whoops! I did it wrong, because these also go up. Oh, that's so much more difficult. Oh, why is it such a mess? Why am I always just making a mess? This, and this. There we go. And then 0 0 0. There we go. And now we basically have a system of weights with which we can control how much of this matrix should... Basically, we have a slider which controls how much we should reset the matrix. So we can set it to be anything we want, and then we can just reset it using this, which I think would be nice and handy. So now what we can do is we can set up a matrix which will be responsible for rotation. I know I'm not making much sense, but these sort of things are much easier to explain once you actually have the graphic ready. That's why... But that's the theme 3 you hear in the background, by the way, also made by Soda. So basically, once I set up this animation, it will be much easier for me to explain why I set up this animation. In order to set up this animation, we would like to rotate it along x-axis, I think would be easier, which means we want y to be pointing down, -1 and 0, and z to be pointing forward, which means 1 and 0. There we go. And now you can see the arrow is basically rotated around the x-axis. You can see the angle between them always stays the same. That's because we basically apply the matrix which rotates this arrow by 90 degrees. So this matrix in 3 dimensions will always rotate any vector by 90 degrees. Isn't that kind of cool? That seems kind of cool in my opinion. Yeah, and now basically we set up an animation where at 0 this will be also 0. And then at 100, where we'll end our animation, this will be a 1. You can see how this... Whoops, wrong way around. They should be 1 right here. They should be 0 right here. Then you can see how this matrix slowly but surely rotates the arrow. Right? You can see how it just moves it by up to 90 degrees. That's what this matrix is doing. I don't know how exactly... Okay, placing this text actually will be a very annoying task, placing this text somewhere. Because the way I wanted to do it is I wanted to place it right here. But in order to do that... that would be annoying. Oh no, that would be... In order to do that, I would basically need to extract the position and rotation of the... Okay, it's actually not as difficult as it would seem. No, let's try it. Let's try it. So, this is our text, right here. This tiny little piece of a node tree is our text. Yeah, it's pretty small. It's just, you know, a bit of a text, right? So this is responsible for these. Now we would like to place them in front of a camera, right here at the top or bottom. I feel like bottom. Maybe would look better. Top. Fine, let's do top. So in order to do it, right here we have a transform. It's kind of master transform for everything. So we can take object info, we can take the camera, and right here we have location rotation. So if we set up transition to location, this transition to 0, I said 0, then there we go. All this text will always follow the camera. Now scale to 0.1 to scale it down, and scale it down even further to 0.0.1. Yeah, seems about right. Now rotation also to that of the camera, and then no, 0, 1, 1, 1. Oh, is it moving along the global X? Please tell me it's not. Doesn't seem to be. It is. Ah, shucks. Or maybe I need to do it the other way around. That's also a possibility. Which means this right here, this right here, just do this, right? So wrong. So wrong. Okay. This node tree puts the text right next to our camera. Right? Oh, why is it so tiny? That's too small. That's the first time I ever said that. Okay, so what we want to do... Wait, vector math and... Okay, that's global XY, not exactly what I want. Align Euler to vector. Oh yeah, that could work. So here's what I'm basically trying to do. I'm basically trying to put this text. I know you can't really see it all that well. Let me just switch the view. This is a camera, and I'm basically trying to put this text in front of the camera, so that it would always be in front of the camera. And there are better ways to do it, for certain. There are certainly better ways to do it. But we're not here to do it smart. We're here to do it at all. Wait, this actually looks pretty correct. Huh. Look at that. I wasn't expecting that to work. Value right here, just to make the adjusting process a bit easier. And Y up. Did this work? It did! There we go! What's this all about? Hi there, Icy. Well, this is all about vectors, trying to do vectors. And there we go. Now we have basically text on screen. I'm good. Listen, I don't mean to toot my own horn, but like, I'm pretty amazing. There it works. We have text on the screen. So now you can see how. So now basically, this is a matrice. This. Can you by the way see it on YouTube? You can. Okay. For a second, I was scared I wasn't streaming the screen. This is a matrice, this is a vector we're applying it on, and this is our result. And now you can see how it's all changing. There we go! That wasn't that cool. Ah, that feels right. This will help with animations a lot. Yeah, now one thing we'll have to do, because I don't know if it's describing rotation at the moment. I mean, it certainly is. right here we can see that this... Okay, there's a lot of text on the screen, I know, I'm fully aware. But you can see that this matrix is definitely rotating this arrow by 90 degrees, right? Right here we always have 90 degrees between them, no matter what we do, because that's just how the matrix operates. The only question is, when it's doing this... Okay, when it's doing this, it's not applying a 90 degree rotation. Because in order to apply the 90 degree rotation, it would have to do it differently. It's moving these arrows in a straight line, so you'll be able to see that from here. Oh, why did it clear everything all of a sudden? We reached the limit of how many things can be written on the screen all at once. Oh no, I don't want to clear anything. Everything, come on. No! Damn it, don't clear everything. I have so many memories. I'm gonna save it as another project, just because I don't want to clear all of this. So we end right here, and we start right here. No, apparently it's clearing it because of a keyframe. Why are you keyframing these? What's going on? Why are you keyframing these? Don't keyframe them! Am I going crazy? I have no idea how this works in Blender, honestly. Okay, right here is where they end. Right at this dot. Right there. Okay. Now you can see that they are just going in a straight line. Like this. This arrow is just going in a straight line. That's not something we want. What we want to happen is we want this arrow to go... I'm sorry. There we go. We want this arrow to go in a... That's not gonna do nothing. We want this arrow to go in a curved line. Because we're trying to describe rotations. How we do that? How would we get this arrow to follow a curved line? Well, the answer is simple. And that is... no idea. These keyframes really are responsible for text. Okay, so... yeah, let's clear all the text to make sure that everything is in order. This is a bit large, isn't it? I mean, I like the placement, but it's taking up a lot of the screen. I suppose it is gonna take up a lot of the screen because... it is 15 numbers after all. How's this gonna look in cycles, actually? I'm curious. Is that a good frame? I don't know, it feels very cluttered. Like there's a lot of things going on, I don't really like it. No, well. That just take 10 seconds to render, that's a lot. That's a lot for an animation like this. Okay. So. I would actually like to add one more thing. Or we can just start animating. Or I can just open up Premiere too. Muff. Festive. Yeah, this is all the recordings I've done so far. And I actually rendered for most of them too, so I guess we could start placing things. No, that's the wrong folder. Oh well. I suppose we could start placing things. Basic. Does this statue on the right have any chance to do another movement when you talk? Would be a cool Easter egg, I think. It's okay. I just use reactive for the little 3D make it in the corner. I mean, I suppose I could. I would have to implement my very own version of reactive in order to do this whole thing. And I guess I could do that. I mean, it wouldn't be that difficult. I would just need to figure out Discord API, and then actually be smooth sailing from there. Okay, maybe in the future I'll make a live stream where I try to implement my own reactive. It's a fun live stream idea. So let's start simple. Oh yeah, you can, by the way, you'll totally be able to get some spoilers for the video, I suppose. Spoiler alert, I know. It's a walking stream anyway. With something that many people yeah, so let's import. And we would like to import not the intro, only these frames. That's how I normally animate stuff. These are all the ready animations I already rendered. Let's start simple, with something that many people consider complex, even though it's not. Let's start with... And right here, we just want to cut right when I say it. There we go. Vector. Why is my Premiere lagging already? That's bad news. Not doing anything. Complex, even though it's not. Let's start with a vector. Most people think of vectors. Yeah, I've rendered quite a few animations after the last live stream. Just a couple, you know, like a solid couple. As just arrows in three-dimensional space, which is wrong. Kind of. It's a misconception. Yeah, it is a misconception. Vectors aren't really arrows in three-dimensional space. They are just numbers. That's it. That's all they are. In reality, vectors are just multiple numbers. Yeah, press up what I said. Make it. Quit copying me. Make it. So why would we think of them as arrows in three? In reality, vectors are just multiple numbers. So, and right here is when I say y. So color, lumetri, color, in fact, and then just plug it in. Saturation down because it's an accent. Why would we think of them as arrows? Right here, I could also add a 3D make it, a little 3D make it too. Because I like adding 3D make it's. 3D make it's always fun. I have a folder with all of the different 3D make it's right here. Poses, there we go. And I feel like expressive. This one, I think. I do not think. I never think. Thinking. No. Oh, actually, that's a pretty solid one. Solid render. I could also pose them, make it myself, but... them as arrows in three... Why would we think of them as arrows in three-dimensional space? Well, let's imagine a basketball with some velocity. And that's another animation already. Animation number 3. Damn, that's it. I really made a lot of them. So this. Well, let's imagine a basketball with some velocity. Velocity. So, for example, this kind of velocity. For example, I'm missing something to put in here because this is a great accent for another frame. But not only that, I'll need another frame. Fortunately, since I do have Blender 4.0, I can just render another frame. Because, I don't know. Basic 1, was it? I think. There we go, it was basic 1. Now we can hide these arrows and we can just duplicate this ball, hide this one, and then right here we can make it go back. right here we can make it go forward, and then we can get rid of these, or maybe not. Maybe we can do. Sorry, how do these vectors work? That's how they work. Can I just unplug them? Transform geometry. Okay, this is for the ball, correct? Yes, correct. Which means if we just plug this in, the arrow is gonna disappear. Festive. And now, motion blur. Why does it look so wrong? What happened? What happened to the ball? Shutter 1 because complete, and that's our velocity ball. Yeah, 3D animating is really not that hard, honestly. It's pretty easy. There we go. Unless you're animating organic stuff, then it's a lot of work. Unless you have a rig set up or a motion tracking suit, in which case it's actually also pretty easy.
Imagine a basketball with some velocity. So for example, this kind of velocity. Now what this arrow represents is that after 1 second the basketball will be...
I screwed up? Did I screw it up? I have a couple of frames I missed there, which seems wrong. But then we have this.
After 1 second, the basketball will be at the end of it.
Yes.
So it will traverse this distance in 1 second.
That's why you use, by the way, units in physics. So that's how we know. So if you, for example, have this vector in meters per second, and if you multiply it by 1 second, you get this vector meters, which means you get the exact position.
That's the velocity. But how would we describe traverse this distance in 1 second?
Okay, that's what we want to end.
Now what this arrow represents is that after...
There we go, and then import yet another frame, because that's what velocity is, I feel like.
1 second, the basketball will be at the end of it. So it will traverse this distance in 1 second. That's the velocity. But how would we describe velocity?
And
the velocity.
There we go. Festive. But how would you describe, I'm guessing, this arrow? I have to go back.
But how would we describe this arrow mathematically?
I was right. I know what I...
Well, we can break it down into multiple different arrows.
Okay, so right here we'll have 3 arrows, so I feel like decent accents are multiple different arrows.
We can break it down into multiple different arrows. We can break it down into multiple different arrows.
I like it.
We can check just how far to the right.
And then I have to repeat the exact same animation because I'm an idiot.
Right, the ball will go, just how far
forward will go.
Forward, just how far
up.
Up. Now we can note down these values, and there we go.
And right here we'll need a manimation. Oh goodness, I forgot I'll have to do animations for this video. I like manim. I do like manim. But it's a bit taxing, I'm not gonna lie. It's a bit difficult to stream and do manim. There's the project nope, that was my machine learning project. Manim, fantastic. Oh, this is for electricity versus electronics. This is for addition to mechanics, which means we want yet another one. Copy, wasn't there like duplicate or something? Apparently not. Rename it to be just 0 math. There we go. And now we just delete all of it. We don't need any of this code. Perfection. Now all we have to figure out. Hi there, Azio. Welcome to Working Wednesday livestream. How to note down vectors in manim. I'm asking manim. In theory is LaTeX, but in practice it differs a bit. Not these kinds of vectors. I mean these kinds of vectors. Yeah. These vectors. Label the coordinate system. That's not gonna help me. That's not really gonna help me. Alright. How to note down vectors manim latex. Do you only work on Wednesdays? Yeah, I only work on Wednesdays. No, on Wednesdays I'm just doing walking live streams. Can you imagine though, if I only... I'm actually not doing anything, I just walk one day a week. Not what I'm looking for. I'm looking for this, kind of. Square brackets, yeah. Binomial. Okay, maybe we should do it in... Wait, binomial 2n, n plus 2. How did you change the... What now? In what universe is that... Manim? What? 1, 3? What is that even? I'm not that great with Python. Seems like some lambda function BS. Alright, fine. LaTeX. Vectors. Notation. What are you working on? I'm a guy. I love the nickname. I'm working on a video, actually. On a video about linear algebra and calculus and other stuff. And Fourier transforms and other. I'm just looking for a simple answer, not these kind of vectors. I'm looking for the multiple... This is what I'm looking for. Input, yes, precisely. Can't wait, neither can I. That's why I'm working on it a bit more. Matrix, oh, that'll be lovely. But that's that guy's package. Don't it? I'm looking for something I can do with manim. Yeah, but vector just puts an arrow, doesn't it? Damn it! Why can't I find a simple answer? Unless there isn't one. Cool to see you walk since you only walk on Wednesdays. Yeah, it's just a 1 week kind of opportunity. Not the kind of vector I need! Yeah, that's an arrow. I don't care for arrows. I care for square brackets with numbers on the inside. I swear I'm gonna do it in Blender. Begin and that's not gonna work, is it? No, it's not. I already know it's not gonna work. Let's try it anyway. Not gonna work is equal to math text this on the inside. Yeah, I already know it's not gonna work. Especially since we probably shouldn't be. Let's try it. Self-play, create, not gonna work. Are you using Linux? No, I'm doing it in Windows because of Adobe. And that's kind of the only reason. I use Windows because of Adobe, and I use Adobe because of Windows. Manim! Animations, fun calc, 0, math, quality low, play. We have only one, so we now have to specify which animation. I just realized I screwed up, actually. I thought I might be using it because you use Firefox. No, I use Firefox because Firefox is just the best. That's why I use Firefox. Did it actually work? I'm sorry, I'm just sitting here in awe and amazement. It actually worked. You mean to tell me it actually worked on the first try? Oh, by the way, sorry, Nitro, for not reading it all. It's just, I'm a bit preoccupied. Oh, it worked on the... That's... How? How did it work on the first try? Well, okay, this just leads to more problems, because now we want to... Hold on. Because now we want to color them in differently. Not gonna work. Well, now my name not gonna work looks really silly, doesn't it? 0 set... Can I? That would be nice. Red Sea. Let's try it. If the entire thing is gonna get colored in... Yes! It's kind of what I was worried about. I mean, we could still try this. Hail Mary, maybe? Oh! There is no way! Hold on! Wait. I'm not used to things just straight up walking. Why is it walking? I'm not used... I wasn't expecting it to get this far, honestly. I really wasn't expecting to get this far. Well, that's amazing. So we have A, B, C, D, E, F. What's next in the alphabet? I don't know my alphabet. Okay. So now, 1, 2, 3. This is 4, 5, 6, 7, 8, 9. So 1, 4. Wait. 1, 2, 3, 4. So 1, 4, 7. 4, 7. Oh, if this is gonna work, I'm gonna be so caffeinated, I suppose. I don't know. 6 and 3. Red. Green. Why is it working? Something must be wrong. Yeah, I mean, yeah. I mean, yeah. There's no way it worked in the first try. I did something wrong. Wasn't supposed to work. There's a tool called Motion Canvas that could help you with animation stuff like that. So I think there's a video. Yeah, but I'm already used to Manim, and the thing is, Manim is in Python, which means that it's really easy to automate a lot of these things. Okay, we're a bit off, but he's got the spirit, right? We're a bit off. Okay, almost there. Almost. Oh, wait. This is consistent, so it's not a memory leak. I'm a C programmer, right? I'm used to. I don't think it requires coding. Yeah, but coding is an upside. Coding is an upside because coding allows you to automate stuff. And also, here's what we could do with coding. We can make colors, which will be... I need colors. Wasn't there like a function RGB? RGB to color. Fantastic. Now what we can do is we can, for I in range 20, I guess, for the future, colors, and not add, only append, if I'm not mistaken. There we go. Append RGB to color and then RGB, which will be 10 times I, 255 minus 10 times I, and then no, well, here we need something different. 100 times I by 100. That's not gonna do much, actually. Motion Canvas only needs some simple coding. I'm a C programmer, right? Like, coding is really not an issue. The not gonna work value is held in my brain. Yeah, not okay, I would need something that'll make this easier to read for me. Why am I overthinking this? Just 10 times I, 255, 255. And then it was gonna go from teal to white, if I'm not mistaken. And then what we can do is we can just, for I in not gonna work 0, I set color to actually wrong range length of not gonna work 0, because we do need the number, and then not gonna work 0. I set color colors I, and there we go. What does the D mean in your HUD? It's a dance HUD, because recently, a couple of live streams ago, I did a quantum mechanics research live stream. I wanted to do a quantum mechanics research live stream, and it didn't go well. It didn't go well, so I just added dance HUD because I couldn't understand quantum mechanics. Never met a C programmer using Python, as you call yourself a C user because you use Python's built in C. Buddy, you have no idea just how much of a C programmer I am. Buddy, you have absolutely no idea. Hold on, I need to prove my masculinity right now. Hold on, someone challenged my masculinity. I need to prove myself. Listen. Listen. I am a C programmer, right? If this doesn't scream mental illness, I don't know what will. I use Python because Python is just straight up better than C. Unless C is faster, but Python is better. I would have to be fool not to agree with that. That is crazy. Thank you, it is. It's not even working, that's the worst bit. It doesn't even work. Okay, it does work, but there are 3 memory leaks, and I'm just too lazy to fix them. Even use some assembly. Some, 4%. I implemented math in assembly because I don't know, I was just feeling like it. Take 1 position arguments, but 3 were given. 1 positional argument? Wait, what? Is it taking... No. Well, that's no help at all then. I mean, egg on my face, honestly, if I spent... Yeah, honestly. I'm the loser in this situation. Because I'm the one who actually coded this thing, so, yeah. Alright, let's delete all of this. And let's just... Why am I overthinking it? I mean, just add another one right here, which is gonna be the purple. And then this one, which is gonna be 0, and it's gonna be yellow. Alright. So, for some reason, this goes 1, 4, 10. 3, 6... I don't get this indexing. 0, 1... Oh, maybe I do get... Wait. 0, 1, and then 2 is green. Oh, I get it. Okay. Egg on my face. Egg on my face. 2, 5, 8, 3, 6, 9, 4, 7, 10. Now it's gonna work. There we go. Look at that. Beautiful. Absolutely wonderful. What am I doing now? Boy, there was a reason.
These values, and there we go. That's a vector.
Oh yeah, right. I just wanted to make a vector. Whoops. Well, this is gonna be useful for the future matrix. Copy this. And vector. Not as singular for now. And for a vector, all we want is A, or actually X, Y, Z. X, Y, Z. And now, if this is gonna work, I'll be festive. Oh yeah, I forgot. Oh, why did I do uppercase vector? There we go. That's what the vector is. 3 different values. Now we're just gonna scale it up a bit. Like 4 should be enough. That's actually perfect.
Forward, just how far up. Now we can note down these values, and there we go. That's a vector.
And then what we like to do is create an equal to vector. So equal is equal to equal is equal to math text equal. Scale 4 next to not gonna work, right? And then vector is equal to math text vector, which means vector v scale 4 next to equal, right? And then no, why did Ellery just all of a sudden delete all the messages? What happened? Set color yellow C. Never challenge make it. festive, right? I think so. Quality high. For now, yeah, I know we're starting the boring stuff because I don't have any cool animations to do right now, okay? We'll get to the interesting stuff soon. You can... just need to explore the videos. 0 muff. 10... There we go. And then all I have to do is just move it to the 3. Almost. Another explorer. That's what I need to do. Muff and right here. Have I ever done full voiceover? No, I haven't even done the full script. I'm 1/3 of my way there. This is kind of 1/3 of the video, or maybe less than 1/3, maybe more. I don't know. I'll have to make the script in order to actually find out. Now we can note down these. And then a pretty cool fun fact for you: if you ever wanna cut out, okay, that's a very relatable fun fact. If you ever find yourself in a situation where you want to cut out a black background from a video like this, then don't use a color key, because that's just gonna, if you use, I mean, you could use a color key for it, I suppose. You could just this, then but that's gonna leave some nasty black edges, and that's awful. Instead, what you can do is you can switch the opacity blend mode to lighten, and there we go. Now the opacity is dependent on the brightness of each cell. These values, and there we go. That's a vector. You can think of very relatable. Down these values, and there we go. That's a vector. And then right here, I suppose we can cut this. Vector. You can think of it as just combining multiple different values. So this single vector is equal to these 3 separate values but that's
combined.
Gonna be misleading,
that's what.
Because when people hear combine, they're gonna think of addition. You're not really combining 3 values into 1. You're combining 3 values into a set of values. So this could be very misleading. I never like that. I don't know if I like that. Alright. Now, even though this may seem obvious, and it may seem simple, and it may seem like something that's just so standard that would be pointless to even write it down in math. Because this. I mean, yeah, it is obvious. Yeah, it is. It is just very obvious. And what sort of animation should I do for this segment? Well, that's a great question. The answer would be camera panning with text appearing. Seems decent enough. Yeah, that's right. Now, even though this may seem obvious, and it may seem simple, and it may seem like something that's just so standard that would be pointless to even write it down in math, I mean, yeah. There we go. Nest as audio segment. Working with soda music in the background is just fantastic. I'm really productive today too. I should make these streams more often. Every day, just a walking stream. That'd be fun. Audio segment. Basic. I want to export it as MP3. That's important, otherwise Blender won't accept it. Oh, that was quick. Look at that. Wrong Blender. Blender 4.0, yes, the same one. I have so many different blenders on my PC, by the way. I don't know. I should clean them up at some point. Open Recent. Basic 2, was it? No, it was Basic 3. Haha. No, it wasn't. It was Basic 2. None of them fit. Which Basic was that? Basic 1. That's the last one I haven't checked. That's why I always do backups, because I know at some point I'll have to go back. Basic 1? Seems like it. Certainly does. Oh, but the position of the ball is all screwed up because I'm Damn it! There's always something. Screw up position of the ball because I just moved it around. Oh no, never mind, I made a copy. Oh, I'm so smart and proud of myself. Oh yeah, always make copies, kids. That's just will come in handy in the future at some point. Is it the same one? No, it looks similar. Good enough. Now what we want to do is make a copy, because always, that always comes handy. And then file, no, add speaker, yes. And then speaker, open, and audio. Distance. I don't think it's working. Generation, how strong distance makes volume? 0. Oh no, because I'm listening to it after the file is done. I'm sorry? What happens to my speaker? Why is my speaker all funky? Why can't I hear anything? Am I going crazy? Is there just no sound in there? Am I going crazy or is my blender going crazy?
Now, even though this may...
I'm not going crazy! I was crazy once. No, this is just not working. Why? I don't like the sound in... Oh, the speaker is right here. Still shouldn't matter. Yeah, it doesn't matter. I don't like sound in Blender. I don't know how sound works in Blender. Because there's always something. Simplify. Is that maybe sound or audio or something? No. Frame range format. No, look at sound. Oh, I need the speaker in Blender. I want to match the animation to... I want to match the animation to the audio so that text appears right when I say it. Just makes it a bit nicer in my opinion. If it was walking, that is. Why aren't you walking? And oh, maybe audio thing stuff system. Yes. Audio sound. Yes. This might be screwed up. Sample rate. Audio device. I don't... Are these devices? They don't seem like devices. These seem like software. Like, not software, what's it called? I don't know, library, whatever. Is my Blender even detecting my audio stuffs? That's a great question. The answer might shock you. Click here to find out. SDL? Let's try it. No. I'm gonna try every single one until I just get it right, randomly. OpenAL. Or maybe if I don't get it right. What's the problem? Honestly, what's the issue? Just play the sound. Why is there no option just insert? Maybe there is. Maybe there's just option 2. Audio. No, that's the kind of audio. I mean, like sound, scene sounds. There must be no this. Yeah, I know this, but it's not doing nothing. volume is already cranked up all the way. These two should be 0. That way I should hear it everywhere, but I don't. Always something. Absolutely always something. I don't know, maybe there's an add-on for it, yeah, no, sound, audio. Something that allows you to play something in the background. It's fine. Blender add audio. You first need a wall so the waves can bounce up to you. Yeah, wait, is that a real thing? No, I'm standing in front of the speaker. Wait, do I just need... Is it really in relation to how close the camera it is? I was joking, okay. I wouldn't know. That's a possibility. In Blender, that's a possibility. Sound to your renders. That's a minute long. Yeah, buddy. Are you adding in a sequencer? Not the kind of audio I'm looking for. Looking for the live animation stuff. You can check what you're doing. I already did it a couple of times. It's just a new version of Blender. Menu only works. No, it does work. Okay, let me show you what I'm looking for, basically. This is an older version of Blender. It takes a while to turn on because I have quite a lot of stuff doing in the background, walking and stuff. Open this.
Now, even though
this
may seem obvious and may seem simple and may seem like something that's just so
you also stream on YouTube? Yeah, I also stream on YouTube. Hi there, Nitro, by the way. Sorry for not replying to your comments on Twitch. I just have Twitch covered most of the time because I'm running out of space on my other screen. New estimated video release date. That's a great question, and I have no idea. It depends. After the last video debacle when with the electricity to electronics. After that last video, I don't want to backtrack again. The sound settings seem the same.
That would be pointless to even write it.
Yeah, but as you can see, this time it's working.
Down in math. I mean,
yeah, this is Blender playing it.
I mean,
this is Blender playing it.
Now, even though
I can copy this object. Don't save. I can paste it right here.
Even though this...
And now it's working! What's going on? What's the difference? I don't...
may seem...
I swear. Magic. Computers are magic, alright? Software and computers are just powered by magic, and that's it. That's the explanation I get. That's all we get. Cool. Let's delete absolutely all of the keyframes.
Now, even though...
Oh yeah, it's gonna be really glitchy and creepy.
This may seem...
And when I say really glitchy and creepy, I mean really glitchy and creepy.
And it may seem simple, and it may seem like something that's just so standard that would be pointless to even write it.
Buddy, you good?
I mean...
Is there a way to bake this, maybe? Oh, wait, 270.
Now, even though this may seem obvious, and it may seem simple, and it may seem like something that's just so standard that would be...
Is there a way to... Wait, wasn't there a way to bake audio? Right here? Update animation cache? That doesn't seem like baking.
Pointless to even write it down in math. Now, even though this may seem obvious...
Yeah, and so basic idea for this is that I want to animate the camera so that the camera would basically go like this, something, just move around, have fun. And then spread these apart a bit to make the animation smoother.
Now, even though this...
Okay, now it's screwed up. Stop that! Quit it! Just keep the audio consistent. There are no effects on the audio. 0, 0. Can I just get like... No, I cannot. It's the answer. Update.
Obvious and... Now, even though...
Oh, update really works.
Oh,
wow.
This may seem obvious and... Even though this may seem...
And right here, the first text would appear. That's the basic idea. Now all I need to do is create new geometry nodes called text, and for those geometry nodes all I need to do is string to curves, fill curve, extrude mesh, set material, new material, which will be, what's it called? Text, that's what I'm gonna call it. Text, and then input the string, and then how does it look? Oh, you have to input the string. God. Festive, it's a bit too thick for my liking. There we go. Also, I like it in the center. Fantastic. And then one last thing, which is switch at the end. Plug this in. And just like that, we have an appearing, disappearing text, which we can modify to our liking. Isn't that just straight up lovely? 9 degrees, and do go on. Oh, that's the theme 3 made by Soda KC on users. Yeah.
Obvious, and this may seem.
And right here is where obvious would appear. I used to do these things by basically making different animations for each text. That would just take so much time and effort and render time mostly, and just very dumb way to do it. And now we can just change it to obvious.
Seem obvious.
It's around 63, which means right here want it to be off and right here want it to be on.
This may seem obvious, and
there we go. Sounds right?
May seem obvious, and it may seem
and then right here would have simple.
And it may seem simple, and it may seem like something that's just so standard that would be pointless to even write it down in math.
I'm not doing the last one. The last one is too much. It's too long. But yeah. Let's see how the focus looks like. What's the topic of the next vid? Math. Math, linear algebra,
simple, and
calculus, Fourier transforms, everything you would ever need to understand quantum mechanics. Just a setup to quantum mechanics. This one would be... What was the last animation we used? I don't remember. We used this one. So we use the vector going up. Demo. It's not really a demo. Math is fun. And linear algebra is very fun to visualize in Blender, because since Blender works using linear algebra. 5.5, that's what this animation should be. Because I screwed up, so 5.5 it is. And there we go, just like that, we just hit render animation and just let him cook. Sick. What's next?
I mean, yeah, it is obvious that...
4 hours. Hi, the Theft! Oh my goodness, hi! Welcome, Theft, how you doing? Make sure you hit save. I'm hitting save on all of them. Hold on, I'm texting on my Patreon only channel on Discord. That's the subtle plug. Nothing, I'm just replying. I was just checking Discord to see any new messages. Hi, by the way, hi the Tefta. For those who don't know, Tefta is the sole reason why I'm still not homeless. I'm just stabilizing some archive footage for the lols. This old chestnut.
I mean, yeah, it is obvious that the end of this arrow has the same position as the end of this arrow, plus this arrow, plus this.
And that's where we plug those in, okay.
I mean, yeah, it is obvious that the end of this arrow has the same position as the end of
this arrow. But this time, oh, but this time we can make this a bit cooler by keeping this in front, giving it a lighten. There you go.
This arrow plus this.
Right here. It's lagging a bit. It's probably because I'm streaming on 2 different platforms and rendering. This
Arrow plus this.
There we go.
This arrow, but even though this setup is simple, that does not limit its potential.
I don't like hearing myself talk, honestly. I don't like listening to myself. I take credit for everything. Well, yeah, you did give me quite a lot of money, so you know, you kind of
Potential of this discovery, because from it you can get
I pretty just called an investment.
potential of this discovery, because from it you can get some pretty amazing things.
And you really can. The linear
Like for example,
addition. And that's the animation that I have been rendering for now. Didn't know you could add audio blender. Yeah. It makes things significantly easier when animating to a specific. Oh boy, 33 seconds per frame. That's a really long time. Oh, hold on, let me just switch to the other one. Is that animation over? Oh yeah, it was over before it. Yeah. Whoops, I'm an idiot. Bro, you have such a calming voice. How could you not like it? I don't though. You have to remember that the voice I have right now is basically the way I sound right now is basically me after training myself to sound decently well for 3 years. I'm stuttering. I'm sorry. I'm just trying to focus on finding the right folder. It's just the point is, the more you talk, the better your voice gets, right? The more you try to talk in a way which is entertaining, the better your voice gets. And you have to remember, I've been streaming every single day for a year, so my voice should be amazing by now. And this is still with parametrics. This is what I sound normally like.
So first, what's going to happen if we add together 2 different vectors?
Isn't that awful? It is.
Addition. So first, what's going to happen if we add together 2 different vectors?
That's a great question, and there is a solid way to explain it, but
vectors. What will the result be equal to? Well, in order to get the sum of these vectors, we just move the second one
on the alright. Your dedication is superhuman. Streaming is not that hard, let's be real. I mean, listen, if I don't know, it just feels like being a YouTuber and a streamer is such an easy thing. It's such an easy job. If I wasn't actually trying, I would, come on. I should really try a bit harder. Like, I'm working 8 to 12 hours a day, but at the same time I'm working as a YouTuber, so I'm not really working, am I? I'm just doing YouTube stuff and streaming. Speaking of charity checkups, https:// make it up with charity / you can go donate to my charity and get a slice of pie for yourself. What was I looking for? Oh yeah, right, different animation. Right now we'll have Blender, I said. Right now we'll have a lot of things rendering all at once, which means my graphics card is really going to struggle. By the way, Theft, you didn't hear that voice crack. By the way, Tefta. By the way, Tefta. Where are we doing the Satisfactory live stream? It was a basic 4, I'm pretty certain. That was addition. No, basic 4 was the new one. Don't crash. Ah, there we go. Didn't crash. Perfection. Blender free. 12 hours a day. I didn't room for sitting that long. Well, I move around a lot. I mean, okay, when I'm rendering stuff, I can just go out for a walk. That's how I keep myself healthy. I love 3D animations because when you're rendering things in 3D, you still have time to do other stuff, whenever it's scripting, going for a walk to think of new ideas, or just doing other things in the house. I'm trying to showcase addition in this case. Not available in location rotation. Is it Rush? I think it's Rush by Soda. And now we just want to move this empty on top of this empty, which should be simple enough. We just need to location rotation. Can I copy the entire vector? Oh, I guess it doesn't matter because I need to input them one by one. Damn it. So I need to input this right here. Okay, they're already on the same height. Great. Now x plus this, y plus this, and z plus this. And just like that, that's what addition is. That's how addition works. I guess I should move the addition down so it wouldn't be in the way. Why? Nope. There we go. That's what vector addition is all about, just moving one vector on top of another one. But that's if you're talking about the vectors as 3D arrows, obviously, because you could also do all of this math without need for 3D arrows, in which case you could just add more dimension if you wanted. When I join AM balls, it feels like I'm productive even when I'm doing nothing. Yeah, it's kind of what the 3D animating is like. Except most of the time I'm not doing nothing. Okay, if I'm only rendering, I still feel like shit, because, well... Did you study maths or something of that sort? Because you seem to have a pretty advanced understanding of those things. I don't have a social life, so... That's always my explanation. I don't know, just... Listen, if explained well, everything is simple. Every single thing in existence can be simple if explained well. I feel like the biggest issue is that most people... For most people, they don't get things... How should I put this? When most people learn about these things, they learn about them at school, where things aren't explained quite all that clearly. And because of that, they just misunderstand the basic idea, and when you misunderstand the basic idea, the foundations are all funky wrong, and then you're having trouble with the entire rest of the topic. That's why when you understand the basics correctly, every door just opens and everything becomes much easier to understand. Also caffeine helps, but that's, yeah. Just me. Anyhow, now we have two animations rendering in the background. Great. Did I show you this, by the way? It's kind of cool. What now? Great question.
To the tip of the first one, or the first one to the tip of the second one. The new vector is just the sum of the previous two, and
yeah, I can't really... Yeah, so for example, right now, we're reaching a pretty annoying point where I can't really 3D animate no more, because all of these renders take such a long time. I mean, this one takes 20 seconds per frame, this one takes a minute per frame. So all of these animations take such a long time to render that I can't really work on anymore, because it wouldn't really be productive. So I need to just do something else. Hi, new fan, absolutely love your content. Your style and quality of content is superb. Hope your channel blows up. Thank you so much, HP. It already blew up. In my personal opinion, it already blew up crazy, because let me remind you that for me, standard amount of views on a video is 2,000. That's a standard. And my second most recent video got 250,000, which is a lot. This is crazy lot. So yeah. Also, I'm still not used to the fact that I have 13,000 subscribers. In my mind, I still have 500 subscribers, so... I think there are two sides of learning. Understanding and using it in real life, understanding the numbers and tricks to solve it. I think both are the same thing, honestly. I feel like it's just a matter of what you are trying to optimize for. So for example, if you want to invent new math, you have to understand it. If you want to solve it, then you have to compute it. So these are the two things. But... how should I put this? Vectors are a great example of that. There are two ways you can understand vectors. You can understand them using this graphical example, or you can understand them using numbers. But both are the same thing. So the real usage of vectors is just a reflection of the qualities of numbers. know I'm not explaining well. I'm trying to think of something else to do. That's actually so true. Even new professors don't seem to be able to explain plainly. I know. I feel like for so many people, it's like a matter of ego, honestly, where they just need to make things seem more complex than they actually are, which is awful. Kinda crazy. Only have 10 viewers. Only? That's crazy high, mate. Okay. This live, pardon the voice track, you didn't hear that voice track. This is my last charity checkup I streamed before I moved on to other channels for gaming, and during this live stream, I had, on average, 1 viewer. Less than 1 viewer. No, 1 viewer or less, I don't know, something like that. So, this is already a massive increase, but schools only teach you to solve numbers. Yeah, that is a big issue. Basically, schools only tell you how to, because that's a misalignment problem actually. Schools, there is no solid way to check someone's understanding of the topic. The best way to do it is just to test them, on how quick they are to solve it, or how, yeah, basically just how quick they are to solve it. That's why you have a time limit on all the tests. That's why all the tests are simple for advanced people, but they still require a lot of calculations, because that's the easiest way to do it. That's why schools aren't all that great at teaching. If you test, the speed of problem solving doesn't matter. It really doesn't matter. When you're an actual mathematician, the speed of problem solving gives you nothing. Just how quickly you can solve a problem, yeah. It's not important though. What's actually important is just how good you are at problem solving. So, how creative you are, how many things you know also comes in handy, because that allows you to link them up. And what's your understanding and these sort of things, not the speed. The speed is useless. Any engineering class newly half the time has nothing to do with solving problems anymore, and more how you can express something using 20 integrals. Ah, lovely. In some cases, a better test would be how good you could explain it to someone who doesn't know. Yeah, right? I always say that in order to ask the right question, you need to know the answer. And that's such an annoying fact, because if you don't know something, for example, if you don't know how linear algebra works, then in order to ask the right question, which would lead you to discovering the answer, you would need to first know how it works, and if you know how it works, then you don't need to answer the question. I know it's convoluted, right? But the basic idea is science is complex. Because of course it is. Science is complex, science is difficult. And there is no easy way to check just how good someone is at science. Because science is complex and because science is difficult. So the best way we found around the problem is to just to test how quick someone is at science. How quickly they can solve problems. How quickly they can bind them to math. How quickly they can do certain tasks. Or, alternatively, just how much do they know. But knowledge and speed do not make a scientist. In science, what actually matters is the quality and creativity, I'd say. Mostly the creativity. It's much easier to check if your solution is wrong than to generate a new one. That's why creativity is so important. Anyhow, on that note, we could actually get some script writing done. We could do some script writing. That sounds like a fun time. That's also why some teachers just can't teach. They test for the wrong things. I know, it always annoyed me so much when I don't understand something, and just I don't even know what I don't understand because I just don't understand. Alright. Shall we do some script writing, by the way? I feel the problem with school is that they always try to measure. Yeah, when a measure becomes a target, it ceases to be a good measure. I don't remember who said that. When a measure becomes a target, it ceases to be a good measure. Music in the background by Soda KC, by the way. Goodhart's Law. See, look at how smart I am. I'm quoting someone, and I'm quoting an actual law made by an economist. Look how smart I am. Aren't I just intelligent? Whoever said that quote could. I'm pretty certain that's not an actual quote, by the way. I'm pretty certain the actual quote was more complex. Any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. That's the actual quote. It is paraphrased as when a measure becomes a target, it ceases to be a good measure, because, oh goody, this quote is non-quotable. Any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. Put that on the t-shirt. Stated as, yeah. Expressing the core idea. Yeah, so this Goodhound actually said a different thing, but then it got paraphrased into this because it's more catchy. Boring science man and make it good. Anyhow. Oh yeah, I'm also looking for a... I need to go, have fun. Well, thank you for joining us. Thank you for joining us, and good luck on your channel's live texts, quantum mechanics. I'm also looking for a textbook, or book of any sorts, about quantum mechanics. Because based on that book, I would like to make a video. The issue is, I need something that would be exact, and also not crazy difficult. Scattering theory. Ooh. That looks interesting. Let's see. Delta function, so it is business. It is serious business. That's a maybe. It's short, it's dense. It's exactly my type. Just like me, for real. I'm also short and dense. Yeah. Oh, I like this. Is it a jackpot? Am I gonna... Wait, is the first one already exactly what I'm looking for? Look how short each chapter is. That's amazing. That seems like exactly what I'm looking for. Short and dense. Whoops, I didn't mean to turn it off. Was that Fowler? I actually already read Fowler. Probability. Yeah, this one's much longer. And see, you end with scattering theory. In this one, you start with scattering theory. That's fun. Yeah, because I'm going to make a video of quantum mechanics, but I want to make that based on some sort of... I don't want to make stuff up, my point is. Alright, this is relatively basic. Relatively basic. Let's see. Some way to calculate expectation value of momentum is to evaluate the time derivative and then multiply the mass. Relatively basic. Differential form equation when J is probability going to find me. Yep. We have integrable parts from the equation. We have again integrable parts as the expectation value of the momentum can be written. Previous equation dot. This will be kind of, yeah, but that's mostly just equation solving more than quantum mechanics. I mean, okay, equation solving is part of quantum, obviously. If you're making a video on quantum mechanics, are you gonna talk about the infamous light slit experiment? I love that. I love that experiment. Infamous? Is it really infamous? I don't know if it's infamous. I mean, it demonstrates randomness really well, so I don't know if it's infamous. I would rather say famous. It's just, I guess infamous because of the whole God does not play dice with the universe sort of thing. But I love that thing. I really dig it, but I don't know, because in order to explain that, we would need to talk about light, and in order... That's just such a random time for epic Popeye. In order to talk about that, I would need to get to light, and I actually don't know how complex light is. like this one. I might need to make another... Oh, Science Saturday. That's such a great Science Saturday sort of live stream, actually. That's a good idea. Well, it's because... Yeah, so it's infamous because Einstein said God does not play dice with the universe. Now, let's see if Maker is smart. Let's see how smart Maker truly is. God does not play dice with the universe. Look how smart I am. Look how much of a smart boy Maker truly is. Look, I can quote 2 different people. Not gonna lie, I'm kind of a big fan of this one. I kinda am. Such a smart boy. Thank you. Alright. Well, that's a maybe. We'll see once we get there. Okay, Saturday I'm gonna make a quantum mechanics research live stream. And once we research a bit more in quantum mechanics, that's when I'll actually know just how long the video will be, what it will be about, and then I'll decide if I'll include light or not. Anyhow, let's script some. How about that? Because we're rendering in the background, there's not much more to do, so let's begin. I'll be there. Yeah, I feel like I should leave the science research live streams on. What is happening? Oh yeah, we're just quantum mechanics. That's what this video is a setup to. This whole video is a setup to quantum mechanics. And in quantum mechanics to chemistry and so on and so forth. Anyhow, yeah, this is a piece of the shorter upload script. And here's the thing, why the music stop? YouTube. Video pause, continue watching, yes. Don't test me. Die, shan't. Anyhow, I'm pretty certain there are only 2 more things, I think, or 3 more things to explain. Yes, there are 3 more things I'll have to explain. So actually Fourier will have a whole separate chapter. Fourier, calculus, and then last one, which is functions. Oh goody. These are the 3 things left to explain in this video. Your video on misaligned AGI, you brought a lot of topics ranging from math to social science together to explain the topic. It would be great if you could do something like that again. Wait, does that say again? I know there's a... Again, yes. Again sometimes. A funny story, actually. That's precisely what I'm doing here. Well, that's what I'm trying to do. I'm trying to go from math to quantum mechanics to chemistry to biochemistry to biology to medicine to... from medicine to social studies, and that's kind of where I'll end it. So yeah, that's kind of what I'm trying to do. Anyhow, when it comes to the script, here's first. It's gonna be fun. Social studies, yeah, you know, like economy, politics, stuff like these. That's what I call social studies because it's studies that depend on societies. I don't know what to call them. I don't know any of the blanket terms for these. Sounds not like a pyramid of science. I know, because it is, and that's kind of what I'll try to do. I'm guessing that those who've seen more of my other videos may already guess what the main theme of that long video will be all about, but for now, we should start the short ones. And also, oh yeah, history. Speaking of, I would also love to make a history video. Oh yeah, that's actually great, but for that I will need to get a bit more famous for that. It sounds awful, but yeah, I will, because... Oh, Dueling Rocks just uploaded a new video. Wow. They just... Wowee. Wow, they just uploaded some new video of stabilizing archive footage. Wow, isn't that a curiosity? It's funny, that's funny. I'm funny. Anyhow. Let me just like that video and then... That's cool. I don't know if I can show it on stream. Just, content steal. There we go. Alright, so I do also... What period of history would interest you? Okay, here's the thing. I have a certain way of making videos. Alright? a certain kind of, I don't want to say theme or vibe, it's more of a certain style, where when I make a large video about a certain topic, I make that video about all the things connected to the topic. So if I were to make a video about history, then I would probably make a video about all of history of Europe. So going from something around 2000 BC to today's age. A video like this, where I would, like animate borders and stuff, talk about historical events. It would be a pretty large video. And surprisingly, the biggest issue I have with making that video is not the fact that it would take a long time or that it would be hard to make. No, the biggest issue is that I would need a genuine history expert to come in. And that's where me becoming a bit more famous comes into play, because I would love to collaborate with Mini Minutemen on this. Because I know they're an expert in history, so once I'll get enough subs to message Mini Minutemen about the collab, that's when I'll do it. In the meantime, we're gonna do some more quantum mechanics stuff and chemistry. Love him. Yeah, he's great. This guy's going to make an entire human archive. I am! Hold my beer. Anyhow. I keep feeling this. Well, I'm not. That's what's so convenient about doing 3D animations. They can just render in the background while we're talking. Oh, this segment of the video. Speaking of, this is actually kind of cool. Okay, so in this segment of the video, I've already explained vectors and matrices. As you can see, there's a matrices explanation, vectors. Now here's where we come to the main misunderstanding of vectors, because you see, so far I've been showing you them as these arrows in 3D space, which is great for explaining their properties, but it's also unbelievably misleading. Let's take matrices for example. If I were to show you matrices only with how we compute them, only with how we compute matrix transforms, so basically with this equation, so the equation in question is... Do I have it noted down anywhere? The equation in question looks like this. Let me just show it. You have a matrix transform, which is A, B, C, D, E, F, H, I, J. I'm pretty certain I missed a letter. Oh well. And then X, Y, Z for the vector. And the way you mathematically do, yeah, alphabet is different. It's good enough. No one cares about G. No one cares about that. The way, the way matrix transformation work is that you get a new vector, which looks like this: XA plus X YB plus ZC dx plus ye plus zf and xh plus yi plus zj. This is... I'm pretty certain, I might have made a mistake, but I'm pretty certain this is a full equation of matrix transforms. This is what this is how matrix transforms work. Which looks insane, right? I mean, come on, let's be real. Like, why? This looks ridiculous, absolutely ridiculous. And if I were to only show you this, then you probably wouldn't understand a single thing. There's just too much multiplication, too much addition going on. It doesn't make sense. But if I were to tell you that these three are actually coordinates for this red arrow, these three are actually the coordinates for the green arrow, and these three are actually the coordinates for the blue arrow, and what we're basically doing is we're basically multiplying x by the coordinates of the red arrow, y by the coordinates of the green arrow, and z by the coordinates of the blue arrow, which means the larger the x, the larger the red arrow gets. The larger the y, the larger the green arrow gets. The larger the z, the larger the blue arrow gets. Then you might actually understand what this means. And that's the same thing, except this time explained graphically. That's why it's so important. This equation, you probably wouldn't understand a single thing. because there is just straight up too much addition, multiplication, and other messes going on. I mean, look at it. It's a mess. It's really funny actually, because once you actually too much actually make it, get it together, calm down, think about what you're trying to say, then say it. It's really funny actually, because once the video comes out, you'll be able to watch the video, watch this exact fragment, and you can then go back to this live stream, and then, you know, you'll see me live scripting this part of the video, and then animating it, then rendering it, then editing it. So I think that's kind of funny, or fun at least. By the way, Teft, are you still in the chat? Oh yeah. Look, it's a mess. But if I were... No, I left. Oh, you are, because yeah, I was just gonna ask you a question. Why are we doing the Satisfactory live stream? I wanna. Friendly Friday? No. It's my favorite game. I need someone to play. I just have this itch. Oh yeah, whenever I just have this itch that can only be scratched with a Satisfactory live stream. But if I were to explain what this equation means exactly, showcase how that works. I'm prototyping this week. I know, that's why I didn't wanna, because I'll be honest, I wanted to do this live stream Monday, but I saw that you were busy, so I just thought I'd leave you alone. How these first three values are the coordinates of the red arrow, these three are the coordinates of the green arrow, and these three the coordinates of the blue arrow. Isn't that interesting? Aren't you all just so glad that you joined into this live stream? I dropped the capacitor on the cab and I found it was... I know, I saw the image. Let me show... Can I show it on stream? Can I show the image you sent me on stream of the capacitor that dropped? Because it is crazy that you found it. Yeah, this is a carpet. This is the carpet. And this little sucker is the capacitor. How did you even find it? Oh, this is... yeah. Main character moment. Desperation. Blue arrow. Oh, magnet actually is my idea. And then if I were to tell you like this coordinate scales the red arrow, this the green one, and this the blue one, it becomes much easier to understand just how these matrices work. It was magnetized by itself somehow. I picked up an electro blade. I dropped it a second time. Yeah, it never works on the first try. But this actually introduces a bit of an misconception. And by I mean awful lot. Sick. Plug this up. Damn, these walking live streams are actually way more fun than I imagined. I was always scared of them, but it's actually pretty fun. I should do them more often. Okay, that's the idea. Every day from now on, if I'm not doing a science live stream, or if I'm not streaming with someone, I'll always just do walking live streams. Because first of all, they're productive, so I'm not wasting time, right? I mean, the more walking live streams I make, the sooner the video is gonna come out. W stream, thank you, Bozo, thank you. Awful lot. That's a nice visual. Is just a visual, not a video, visual. This equation is the underlying math. What do I mean by that? And that's actually okay, and this is actually pretty cool, because right here we come to the point of the video where I get to explain something which I tried to explain in the past multiple times, but always failed to explain it well, which is dimensions. Oh yeah. Well, let's consider a matrix transform with 4 values. So 4 by 4 matrix on a 4 number vector. Dimensions. Yeah, I really don't like dimensions because they just introduce people. Whenever people hear about something like, I don't know, 7-dimensional function, they get, they get scared because it sounds awful. 7-dimensional function is crazy. When in reality, all it means is it just has 7 numbers in it. That's it. That's all it means. 4 number vector. We already know what this means. Just apply the first one. First scalar. Oh, this is gonna be such an annoying animation to make. I just realized I'm throwing my future self under the bus with just how annoying of an animation this will be. Oh well. Dodge using 5,000 dimensions. Yeah, I mean, in the past, when I was doing machine learning, I was basically trying to solve a derivative on a 50,000 dimensional function. But it wasn't hard because dimensions don't make things harder, they just make things larger. And I was also not really solving. I guess I wasn't solving a derivative, I was computing a derivative. Doesn't matter. The point is, it sounds scary when in reality it's just boring most of the time. First scalar. Second by second scalar. Third by third. And fourth by fourth. You learned machine learning? Yeah, that was really long. Well, okay, I learned machine learning, then I did machine learning, and then I learned some more. I made videos about machine learning. I don't know. 2 of my, I think, these. I love these videos. These are all about machine learning. These 2. About AGI to be specific. But yeah, AGI is machine learning. This is the end goal of machine learning. Third by third, fourth by fourth. Second scalar, third by third, fourth by fourth. Just add them together. There we go. We just solved a 4-dimensional matrix transform. Now let's imagine we try to do something like this in 3D. Well, we start with nothing, and then just black screens. Yeah, funny. Speaking of AI, what are your thoughts about computer-generated images? Controversial. So my thoughts, I mean, I think they're really sick, but I feel like a lot of people have a lot of misguided feelings towards them. Because there are a lot of people who are really mad at computer-generated images, but they are mad about the wrong thing. Basically, a lot of people are mad about just how AIs are being used. And because of the blaming AI makers. For example, where should I start? Like, for example, many people are upset that AI image generation is gonna basically gonna replace artists, right? Just numbers, creating more numbers. Technically, yeah, but you know, many people are scared that AI image generation is gonna replace real artists. And many people are mad, many people are scared. But the thing is, AI's replacing artists isn't bad. What is bad is AI's replacing artists for a profit motive. For profits. Their just might is being commercialized. Exactly, yeah, that's the problem. The problem is not AI's, the problem is the way it's being used, and the way it's being used basically for profit. If AIs were being used for the general good of everyone, then it wouldn't be a problem, but... So that's the issue. Everyone who's mad about AIs isn't really mad about AIs, they're just mad about capitalism. And because of that, there's a lot of misguided anger, like for example, OpenAI gets a lot of shit, which they really shouldn't because they're amazing. They are amazing, I love OpenAI. But they're getting a lot of problems because of capitalism and how the things are being used. Which is annoying, because they're pretty amazing. Really. This sentence is a bit of a lie. That's why I said a good way, because technically you do it with time or call level or whatever. OpenAI has one of the nicest environments to work in. Yeah, because it's a non-profit. For goodness sake, it's a non-profit. Research organization, yeah, it's a non-profit that tries to create AGI, and that's cool. That's like the best goal to have. There is no better goal than to create. Oh yeah, they also released this one recently. A lot of people are upset, but I think it's also pretty awesome. You can see some glitches, but it's still impressive. And I'm just upset because there are... So here's the thing. I'm pretty good at science, but there are a couple of things that I'm not really good at. Like for example, art. I'm not great at art. I'm not... That's why I'm so... Downloading 16K files doesn't work well. Horrible at that. You just... wait, I agree. Well, that's mean. I mean, it's cool for me to say, but there's no need for you to agree with me. No, I am horrible at art. That's why I'm so fascinated with people that... Sorry about that. That's why I'm so fascinated with people that are actually good at that. I apologize, I was joking. I'm so fascinated with people that are actually good at art. But my issue is that I love AIs, and people that love art really often hate AIs because AIs, you know, seek kind of to replace the artist. Which is wrong because AIs don't really seek to replace the artist, only people that are doing things for profit seek to replace artists. I mean, it's nice that you can more easily create things using AI because art is something that takes a lot of talent. I know, and the thing is, AIs replacing artists is not that big of an issue. AI replacing artists for profit is a big issue. And because of that, I just... One person which I tend to watch for all of the art takes is Simbib, kind of my comfort YouTuber. And they released a video about AI machines evolving. It learned fake video about this, about Sora, and that video is awful. I just really don't like that video. That video was just straight up awful. Because they're just so angry at OpenAI when they shouldn't be. Be angry at the corporations that are using it for profit, not at my boy OpenAI, my beloved. Leave my non-profit alone. Anarchist capitalism. Controversial. Not getting into politics. Anarchism, but the capital. I don't know about that. I don't really like the arguments of, you know, some political system is awful, so ours must be great. Because that's kind of like saying, you know what, getting burned to death is awful, which means getting freeze to death is actually pretty cool. It's not, yeah. Just because something's better doesn't mean it's great. I feel like... I'm a transhumanist. I just believe that humans... I just want that robot body. That's all I want. So I downloaded 16,000 files at once from US Archive website. It maxed my RAM. Wait, US Archive? What is US Archive? National Archives? What is it archiving? What were you downloading? What were you downloading? What? 16,000 files? I mean, archive makes sense, but still. Take a wild guess. Oh, you just said Steve asks me if I wanna. Yeah, go to website, go to site. Oh, okay, that makes sense. I actually had, okay. I wouldn't have guessed that because I had no idea you got this from National. Okay, makes sense. And okay, that's reasonable. Anyhow, what was I doing? Oh yeah, right, script. And that's the biggest misunderstanding there is about vectors and linear algebra in general. My opinion. Linear algebra is great explained using, can be explained well. English make it can be explained well. Fourier is a funny word. Fourier is a lovely piece of math. That's all I can say. We're using dimensional arrows because these arrows can be visualized using numbers. So this explains linear algebra well because it uses linear graphic way, but not the other way around. Arrows come from linear algebra, not algebra from arrows. That's why. Can you imagine just going back to whenever Fourier actually lived and just saying in the face, haha, funny name. That's why what? That's why, even though it may seem really difficult, solving math for four-dimensional objects isn't that much harder than solving it for three-dimensional objects. Alright. Poor French guy just got bullied for being bullied for his name. Wait, no way, Fourier was French. No, you're joking. No, it's disgusting. Ew. Ew, it was French. Ew. That makes it worse now. Yeah, it does. That's awful. I feel like my brain just naturally rejected that idea because I like Fourier transforms. Oh no, they're French. No. I thought it was just a funky English name. Ugh. Transforms, I really want to be French. I want to transform and say, yeah, that's awful. No, my hero. My hero's my hero no more. But since I discovered he was French. Funny story. Our only Discord admin is French. Then solving it for 3-dimensional objects. What's even better is that once you as you generalize something math, you can solve it for any number. That once you generalize some sort of transformation in 3 dimensions, you could apply it to important thing. Remember, when you hear some sort of n-dimensional phenomena in the map, doesn't actually mean this many. Welcome to Make It Keyboard ASMR, everyone. Welcome to Make It is Losing It podcast, episode 6. Oh, that'll be a good one. Oh, back then I didn't have a mechanical keyboard. Oh, I could make that one. Make it aggressively scripting a video. That's a great podcast idea. There we go. Oh, by the way, Tefta, did you see the Make It Shitpost upload yesterday? Oh, I have to switch my account. Because I feel like it's kind of funny. Did you see this one? I'm really happy with this one. It's kind of funny. I was really tired when I made this. I mean, when I was streaming this, not tired when I made this. I love Tethas there. I also love how Tethas while you're walking on something important in the background. I'm just, yes, how to use phone, can't use computer. Yeah, I know. Yeah, as I mentioned, Tethas is probably walking on something in the background. I'm just constantly interrupting. Stepped up your vlog trying to give it. But it's funny because the robot was actually responsible for one of the puns in there. It was funny. Thank you. Actually, I mean, not really thank me. I guess it's been just us. For those who don't know, it's just a clip from the beginning of the live stream. There's a question for where these are the real problems, honestly. Nothing better than eating an arm. I mean, it's candy and everything. Just make puns. You know. We just ate some human legs and arms. Listen, I know that I can be a handful at times, but like, just kept going. Yeah. I mean, you know, we're kind of fucking. It's a step up. It post up. There were so many too. That's pretty good. All right, let's carry on. Carry on the live stream. My taskbar is not working on the other screen, so I have to turn on my Twitch and the OBS right here. All right. Doesn't actually mean this many dimensions. Only means this many numbers to solve it. So if you... Okay, what would be a good example for that? Something with many numbers. Something with many numbers people can relate to. So for example, if you have... Can't I think of anything? Damn it. If you, for example, have a video game with 10 players, then you can note down all of the healths as a single string of values. Or in other words, you can create a 10-dimensional vector Yeah, there we go. Sounds ground, but actually is it? That's what dimensions are. Just multiple numbers. So next time someone brag about solving an 8-dimensional function, I really want to make an oversimplified reference here and say kick in the groin, but punch them in the face. That's gonna be good enough. Oh, you know what? Yeah. Wait, was the actual quote? Hold on. I want to make this into an oversimplified reference. It was from. Let's go. I'm pretty certain it was here. The largest. Hold on. It was. That was nod. It was the largest naval battle. I'm pretty certain ever. Wait, was it really not in this video? Was it really the part
This
one?
video was made.
It was. It has been made possible with NordVPN. I would recommend, by the way, really great videos. No, that was before the war. Come on, I can't find the segment. I want to quote it directly, otherwise it's not going to be a cool enough reference. There we go. There we go.
Kick him in the nuts.
Kick him in the nuts. Okay, it was. Okay. I know my oversimplifieds. And there we go. And there we go, actually. That's what we're gonna put in the video too. And there we go. Now with 6 of linear algebra behind us. I'm saying basics because, oh goodness, I forgot. Eigen. Vectors, values, and whatnot. Oh, I forgot about eigen stuff. Damn it. So to explain eigen stuff. Alright, it's fine. There we go. Basically, linear behind us. We can finally move on to functions. I'll be right back. Just give me a second. If you all wouldn't mind, I'm just gonna. I'll be right back. Alright, 2 seconds. Stop. Okay, maybe 4 seconds. Yeah. 4 seconds stops and I am back. Right here. Got back in time. Anyhow, what are we doing? Oh yeah, right. How are animations? Not done. Of course they're not. Alrighty. 3 minutes per frame. It's not just lovely. Okay. We can finally move on to end and functions. So, when it goes to functions, how will I explain functions? That's a great question. Okay, functions would be I should keep functions short because it's not that complex of a thing. It's just functions. That's all this. Which means it's basically an equation into which we insert a value, an unknown, and based on that unknown we can create a function. Yeah. How to explain it now? One input, one output. Well, yeah, but you know, it could also be two inputs equals one output, and one input equals two outputs. That's the issue. It's really not one input equals one output. And what's even better is that in quantum mechanics, you will have multiple inputs equals one output, or multiple inputs equals multiple outputs. So that's a problem. Oh, I guess multiple outputs is not really the case with functions. Is multiple outputs the case in functions? I don't know. I don't think you can have multiple outputs. I think then you just need multiple functions. One output with multiple components. You could have a vector as an output. That's multiple outputs, and has a single output with multiple values. What was I talking about? Where am I? What am I doing? Oh yeah, right, functions. So, to start, let's start with this. An equation from board equal, because the left side of the equation is equal to the right. This could be decent enough start to the right. Now let's insert. I feel like I already explained it. I feel like I'm explaining it the exact same way as I did in quantum mechanics, so additional quantum mechanics. Defined as always giving the same one output of a given input. Yeah, then I was way wrong on this. Yeah. That's, yeah. But it can have multiple inputs. And in quantum mechanics, it almost always has multiple inputs. Unfortunately. Or maybe not unfortunately. Well, time always screws everything up. It always does. So there's the right. This seems simple enough, but now we can. Seems simple enough, and I feel like it doesn't really require explanation, since we all kind of get what equations are all about. So let's have some fun. Okay, for this I will need to note down the equation I'm going to be working with in order to script it, because so the basic, yeah, I'll just explain it the exact same way as I did in addition to quantum mechanics, because that's a good idea. I don't know, it's a good explanation. I don't know how to explain it better. Like, how would I explain it better? So basically you have an equation, something like 4 plus 1 divided by 3 times 6 times 6, and then just showcase how if you increase this, then the whole thing increases. If you increase this, then the whole thing decreases all of a sudden, which is weird. Let's have some fun. Place the 1 with a 2. Now, because this is equality, both sides change to remain equal. I'm also thinking, what should I use as a visualizing thing? So either a classroom, or we could have a weight, where it basically tips to always be equal. Although the weight, I feel like that might be a bit much. So remain equal. So since we added 1 to the left, we also add 1 to the right. Isn't it more natural to look at function not as an equation but instead as a transformation of values? Yeah, but how would you introduce that? How would you? Because you have to remember, at this point in the video, I haven't talked about variables. I haven't mentioned variables once. So basically, I'm going in without variables explained. So first I'm trying to lay the groundwork for variables, and then using variables, I'm trying to introduce functions as graphs showcasing the change of an equation based on a variable. So, and there is a sneaky reason for why I'm doing this. So basically, I'm trying to explain an equation like this: 4 plus 1x times 6. I'm trying to showcase this function as just a function showcasing how the equation changes as the variable x changes. And the reason why I'm doing this is because it's such a smooth segue to calculus. It's just an outstandingly smooth segue to calculus. Because once I'm done with this, I'll just basically ask the question, alright, cool, so now we can see how the function changes. Now we can see how the result changes. So the next obvious question would be, how can we measure this change? And there we go, calculus, derivatives which don't make sense because 0 divided by 0, so limits. After limits, integrals, because just the opposite of derivatives. From those we get to Fourier transforms, and from those I'm like, psych! There's one more thing left to explain, and then eigenvalues, and then fame, fortune, forever, done. That's how I was planning on doing it. Which means, well, because I want the right. Now let's replace the 2 with a 4. Once again, we added 2 to the left, so we to the right. To keep things equal. Alright, but now what's going to happen if we... I've had equations explained to me once, like wanting to buy something with a given amount of money, and the thing is, if I want to know how much I get before I get I need a function which transforms the amount of money I have into the good I can buy. I don't know, because then I would need to jump into it explaining functions without variables. As I mentioned, this is a great segue into calculus, which will be convenient, because, you know, then I won't need a setup for calculus, the setup will be already done in functions. What's going to happen if we replace the 1 with a 2? Well, we've 1 here. We have to add 6 to the right. This, well, in order to keep things equal, we have to add 6 to the right. Hold on now. We've only added 1 to the left. Why? 6 to the right. What's more, if we replace the 3 with a 4, then we need to subtract from... Damn, I retype slow, don't I? Result. And then what's going on is kind of obvious because we all know how basic division and multiplication works, and so on. I'm kind of scared of the eigen. Fourier will be easy enough, relatively easy enough. I'm kind of scared of the eigen. And once again, I'm sweeping just more stuff under the rug because in the quantum mechanics video I'll still need to set up a couple of things. Start explaining what the wave function is. How would you explain logarithms visually? I wouldn't, because it's silly. I don't like logarithms because logarithms are kind of created in such an abstract way. It's just dumb. I don't like them. They're created in such an abstract way. You can't even... Okay, it's difficult to even explain exponentials visually. Because exponentials by themselves don't really appear anywhere. Division is also abstract. Yes, it is. That's why I also don't really... That's why I don't explain... Okay, here's the thing. Yeah, division is abstract. That's why, I don't know if you've noticed, but in my addition to quantum mechanics video... Oh, wrong count. Doesn't matter. The point is, in my addition to quantum mechanics video, I've never mentioned subtraction or division or roots. Even though they are operations, they are just inverse operations, which means division is just defined based on multiplication. Subtraction is defined based on addition. And so, for those, you don't need them. Let me show you what I mean, paint. Oh, I have paint open. That's awful. Paint. Wow, what's happening? Windows. Wow, that was a... Oof. Is it the animations I'm rendering in the background? I don't know if you saw that, but I felt it. I felt the crunch. So for example, A minus B, you can just define it as A plus B times minus 1. Then A divided by B, you can set it up as A multiplied by B to the negative first power. So you don't really need these, as long as you have negative numbers, you don't really need these inverse operations. That's why I didn't explain them, because, well, subtracting and dividing explained only using multiplication and powers. So you know, you don't really need them in theory. Logarithms, once again, are this sort of abstract kind of mess where they only exist because of, as a way to solve exponentials, but in reality they don't really help with solving exponentials, they're only notation for them. It's kind of like saying that A plus A times B. It's kind of like saying that this would be some sort of function, this, and then asking someone how would you explain it graphically. Well, it's just a made-up function that someone just made up to them, so yeah. The point is just made up to... was made up to problem solve. It's the same issue as with imaginary numbers. Like, how would you graphically represent imaginary numbers? You can't, they're for rotations. You can graphically represent rotations, but you can't really graphically represent imaginary numbers. The same way logarithms were made for exponentials, and so you can graphically represent exponentials, you can't logarithms. As a coordinate system. Yeah, but as a coordinate system, it's not really accurate because this coordinate system is dependent on the other one, so... Again, paint. If you have a coordinate system like this, right, we have you have 1, 2, 3, 4, and then -1, -2, -3. Then if you multiply 2 by 2, you go to 4. But if you multiply -1 by -1, you go to 1. So you go right. You're always on this line. If you divide 4 by 2, you go left. Right? If you divide 1 by 2, you go left. But if you divide... No, wait. Powers. Yeah, make it powers. If you square 2, you go right. If you square 3, you go way right. if you square -1, you go to 1. Now roots, that was a very long setup. I really want to go over every single operation to build up for some reason. Now roots, once again, just like multiplication goes right, division goes left, powers go right, roots go left. 4 to 2, 2 to something right around here, and then 1 to 1. It just loops. These go up. But when you root -1, you all of a sudden go up. That's why explaining them as a coordinate system doesn't really make much sense, because it screws everything up. Multiplication doesn't always go right though. I meant with positive numbers. The issue is, you can't really explain it as a coordinate system because the numbers on top, imaginary numbers, have certain properties which real numbers don't. And you can't have that with a coordinate system. With a coordinate system, you need each coordinate to be equal. So, for example, if you have an honest coordinate system like this, with coordinates x and y, then you can't, only using y's, suddenly go to x. You can't switch it that way. On the other hand, right here, you can, only using i's, go to x. Go to real number line. Because you can just do I times I times I times I, and all of a sudden you're at 1. Even though you only use these coordinates. If in this coordinate system you do y times y times y times y, then you'll get just y fourth, which means you'll go way up, which doesn't happen right here. Right here you just go back to 1. Doesn't make sense. That's why it's not great as a coordinate system. It is used on a complex plane for rotations. But those operating are an equivalent. What do you mean by that? Multiplying complex numbers just has different definitions. Yeah, exactly. And that's what makes them for such an awful coordinate system. This coordinate system is used to do rotation, not as a okay, I mean, awful is obviously a subjective word, but my point is you can't really represent it graphically using real life things. Just like you can't represent logarithms. It doesn't mean they don't exist, they just exist as a consequence, and that's why you can't explain them graphically. You can have 7 apples, you can have 2 apples, you can't have -2, nor can you have imaginary 2. Well, in polar coordinates, the repeated multiplication would lead to a full circle. Yeah, because they're polar coordinates. But I don't know if you noticed, in polar coordinates, you don't have one coordinate representing this axis and another representing this axis. You have one coordinate representing the distance from the center, another one representing the angle. Okay, so if you want to use polar, okay, if I were to compare it to polar coordinates, it's as if theta affect, okay, so it is theta and what, h, I think? No, theta and r. Imagine if theta somehow affected r. Imagine like if you multiplied theta to the 4th power, it would somehow change r. Then the polar coordinates would also be pretty awful. Because then that means that rotating around the center would somehow affect the distance. That's the issue. The issue is that this affects this. That's why it doesn't work that well as coordinate system. You need to keep the two values separate for an effective coordinate system. Well, a plus b I always dependent. Yeah, that's why they're an awful coordinate system. If you have x plus y, obviously ax plus yb, then these are independent because in this case x would be 1, 0 and y would be 0, 1. No matter what you multiply them by, you only multiply this number and this number. These stay as 0. You can't have two coordinates be dependent on each other, because then it leads to mess. For example, there's a term for it in linear algebra, when you have two coordinates that are dependent on each other, which basically means that, well, actually no, how should I put this? If you have two on the same line, two coordinates like this, then you don't have two dimensions, you have a single dimension. There is a term for these basis coordinates, there was a call it, I don't remember. Mess isn't the right word because in engineering it's much easier to use complex numbers, but are you using them as a coordinate system or just as complex numbers? My issue isn't with complex numbers, it's with using them as a coordinate system, because we almost never use them as a coordinate system. It makes mess. Yeah. Imagine you're playing a video game where you have your character and you, for example, would have a surface which looks like this wouldn't be exactly a sphere, more of a cone, doesn't matter. The point is, you have a surface like this, right? Now, here's the thing. The lower down the character, the higher the slope, right? So on top it's flat, the lower down you go, the more the slope increases. You can describe it like so. The further away from the center the character, the higher the force pulling them down, because there is a higher slope. So basically, I don't know, force F, whatever, just it can be a scalar because it's only going down, which means that equals Fx, something like this. Now the issue is that this isn't really curvy, isn't linear, it isn't going like this, which means F equals Fx isn't quite exactly accurate. The higher the F, the more the F is affecting it, which means that given a certain kind of curvature, you would need Fx, F squared. Or rather Fx squared, sorry, this way. And x on this side, whoops, screwed up. Anyhow, and r squared, what am I doing? R squared, obviously. This one. If you have a surface which would be a parabola, then this would be the equation describing the force pulling them down. The issue is, if you were using imaginary numbers for this, then on this side, right, on this side you would just have x squared is equal to f, which means the lower you go, the more the force increases. Which means if you are, let's say, 5 units away, or actually no, for the sake of this, 2 units away, then the force pulling you down would be equal to 4. Which means if you're 2 units away, it would just pull you down with a force of 4 units per second. But if you have the other side, you would use the imaginary system, which means imaginary squared would give you F, which means all of a sudden the force is equal to -1, which means if you slide off on this side, you're sliding down faster and faster. If you slide off on this side, all of a sudden you start going up. That would make them for such an awful coordinate system, because it would just screw everything up. If you use polar coordinates, once again, it's still not a problem, because if you use polar coordinates, you have an angle, right, theta, and then you have the distance from the center, which just makes things easier, because right here you would use r squared is equal to f. And using polar coordinates, this would also be valid on each side. using standard coordinates, Cartesian coordinates, you have x and y, which means you would need to use x squared plus y squared square root, if I'm not mistaken. I think that's what you would need to use in order to then get just the distance from the center. Right? No. Hold on. X, y, yes. Because this would give you the hypotenuse. So this, you would use this to get distance from the center, which means that square x square plus y square. With imaginary numbers though, it wouldn't work because imaginary numbers are dependent on the real numbers in their definition. They're great for describing rotation because they can do something no other number can, which means they can oscillate imaginary numbers when you increase up e to I theta, right? They can oscillate back and forth, and that's why when you're using polar coordinates, you are actually using distance from the center with theta, but theta has to kind of oscillate back and forth. If you're trying to describe this rotation with, if you were to actually just set up a circle using Cartesian coordinates, so if you were to try to create polar coordinates based off Cartesian coordinates, then what you would need is you would need distance from the center, and then you would need an angle described as a point on a circle using x and y. And then, in order to describe that, it would have to increase forever, and for this you would use e to the theta I, sorry, which would just... Hold on, am I doing that right? E to the theta I... No, I'm doing it wrong, because you need x and y, which means you would need x and y to give you I. The point is, you can, using imaginary numbers, convert Cartesian coordinates to polar coordinates, but in order to do that, you need x, y, and I. You need three different things. You need two as units and one as a oscillating back and forth type of thing. What was I doing? Oh yeah, right, rendering. That's still 77. This one's 6 away. I feel like I should end today's live stream now. It's been 3 hours, and at this point all I have to do is just wait. So I don't want to turn it into a paint drying live stream, so I suppose I'll go for now. I'll just work on the rest of the video in the background. Saturday we'll do a science research live stream. Saturday science live stream where we'll just research some quantum mechanics for a video, possibly also some chemistry. But anyhow, thank you, Bozo. Yeah, we had a good talk though. That was a pretty nice talk. I like it when I'm talking with people who actually understand science. Always feels nice. Good talk. That was a really good talk. Anyhow, as always, https://make-it-up// we can go to charity and get a slice of pie for yourself. That's the point of the last stream. Charity DBS Alliance that we're collecting money for right now. Anyhow, music in the background was from SodaKC, youtube.com/@SodaKC if you'd like to listen to more. And for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.